Good morning. How are you guys doing today? I'm excited to talk to you guys later, or at least some of you, 5 of you, about the AP Stats test, which is coming up on the 22nd. Should be pretty cool. Okay. So today we're doing independent two-sample t-testing, essentially. So if we have two populations and we're comparing them to each other and we don't know the standard deviation, what do we do? So there's a nice little flow chart to begin here. We're going to spread out 8.2 over 2 days, so today and Monday, because there's two main types of problems in here and they take a little bit of time to do, especially on your own. So let's see, it says that on the flow chart here, the first question is, are both population standard deviations known? And if the answer is yes, and the population is normal or both sample sizes are at least 30, then you can use the z-test. This was section 8.1. We did that together. If the answer is no, then you've got to ask yourself, are both populations normal and are both sample sizes at least 30? And if the answer is no, then you can't do it. Are the population variances equal? So that means of the two populations, are the standard deviation, which means that the variances are pretty similar, or at least known to be, not necessarily in your sample, but known to be ahead of time. If the answer is yes, you're going to use a t-test with a absolutely horrible thing. And if it's no, you're going to use a t-test with a less horrible thing. So this is what we're going to be doing today here. This is 8.2. Let's see, yesterday was 5.7. Today is 5.8. And here's 8.2 part 2. And this will be 5.11. Almost done. Just got to finish up this chapter, and then we're all finished with everything that's on the AP test. So we're very close. Okay. This goes on about two-sample t-test and what to do if the variances are equal and the variances are not equal. Essentially, what you have to do is you have to figure out what goes on the bottom of this fraction. Because it's always going to be x bar 1 minus x bar 2 on the top minus mu 1 minus mu 2 on the top. And remember that 0 from yesterday. And then the thing on the bottom, it depends on if the variances are equal or not. So today, again, we're doing this one down here. The variances are not equaled. When variances are equal, it's called pooled. A pooled estimate is kind of like we're kind of looking at the variances together. And when their variances are not equal, it's called not pooled. This is this one, the pooled one, which is one we'll be doing on Monday. It's probably the grossest formula in all of AP Stats, so have fun there. Okay, so it says if the variances are not equal, then the standard error is this, which is what should be going on the bottom of that fraction right there. So I'm going to rewrite this equation right over here. So t equals, I'm going to keep the top. This is x bar 1 minus x bar 2. Minus mu 1 minus mu 2. Remember, mu 1 minus mu 2 is essentially 0. And then on the bottom goes this mess right here, which is the square root of the first standard deviation squared divided by its sample size plus the second standard deviation squared divided by its sample size. So that's the actual equation you'll be using, very similar to yesterday, except for s's in places of sigma. But tomorrow it won't be so pretty. It's going to be nice and gross. Luckily, your calculator also does this, so I'll show you how to do that, and you're allowed to use that on your AP exam. Okay. So, I just copied the t-chart here to help you out, so that you don't have to write it yourself this time. And I think it has way too many steps. I would have combined a lot of these, but we'll just go with it for now. So verify that they are unknown, sigma, and both sigmas are unknown. The population is random and independent. The population is normal or bigger than 30, and both of them are. That's important. Both of them are bigger than 30. We're going to do the normal stuff, state, H sub O, and H sub A. The degree of freedom depends on whether or not it is pooled or not. So let's see. Remember, we're doing the not pooled problems today. So if you look back on this one, variances are not equal. The degree of freedom today is the smaller of n1 minus 1 or n2 minus 1. So you've got to pick which one's smaller there. Remember, degree of freedom usually is just your sample size minus 1. So this time we just look at both sample sizes and subtract 1 and then take the smaller one, which is not the same rule for pooled, but we'll talk about that tomorrow. Okay. So today we're using this one. This top one is for pooled data, and this is for not pooled data. Then we're going to use this formula, and remember that bottom part, that depends on whether the variances are equal or not. Alright, let's take a look at example 1. The results of a state mathematics test for random samples of students taught by 2 different teachers at the same school are shown on the left. They are absolutely not shown on the left, so let me just write them in quick. Teacher 1 had an X bar 1 of 473 and an S1 of 39.7 and 1 of 8. And the only reason why there's 1s there is because it's teacher number 1. That's it. Teacher number 2 had apparently slightly worse test scores. But this teacher had them more spread out, so I wonder if that teacher just had a couple kids that were like doing amazingly well. Also, look at the sample size. This teacher teaches 8 kids, and the other teacher teaches 18. I mean, come on. More chances to have a genius that really affects your data if you've got 8 kids in your class. Alright, so we're going to go back to the steps up here. Step 1, verify that they're unknown and that it's normal and or both are bigger than 30. Okay, so definitely n's aren't bigger than 30 on this one, but it does say that it's normal, so we're good to go. I also know that it's S, not sigma, because it says right there, S, it's just a sample. There's no sigmas in the problem. Alright, sounds good. Step 2 says we have to do the null and alternative like usual. Alright, so they're talking about teacher 1 and teacher 2, and their claim is that there's a difference, which means that their claim is that these are not equal to. These teachers are not the same, not performing at the same level. Okay, next we have to identify the level of significance. That is alpha equals 0.1, 10%, and the degree of freedom. Okay, so we need the smaller of n1 minus 1 or n2 minus 1. The smaller one is definitely 8. So I'm going to write down that my degree of freedom right here is 7. Alright, next thing I'm going to do is draw a picture and draw my rejection regions and critical values. I know it's a two-tailed because it's a not equals 2 problem. And then if I look up on A18, and if I look